Hi, today we're going to work on the Mometum Problems 2014 worksheet. At the top of the sheet you can see the equation we're going to be using for momentum. P stands for momentum, M stands for mass, and V stands for velocity. The directions instruct us for the following problems. Be sure to show your work and circle your answers. If you do not clearly show your work, it's wrong. We also want to remember to always show our givens and our unknowns using that guess method. Number 1 states, what is the momentum of a 0.30 kilogram blue jay flying at 17 meters per second? So I'm going to go ahead and write my letters over here. And I can see that I have my mass, so I'm going to fill that in right here. And I have my velocity. So I'm going to go ahead and set up my equation, P equals mv, and I'll fill in the variables I have. I'm going to go ahead and punch that number into my calculator, and I get 5.1. This is going to be kilograms times meters divided by seconds, and I'll go ahead and identify my answer. So when I go back and check, I have my variables, I have my unknowns, I have my equation, I have my math, and I have a circled or a squared answer. So number 1 is complete. Then I can move on to number 2. What is the momentum of a 650 kilogram car moving at 3.5 meters per second? I'm going to go ahead and fill in my information. I'm looking for my momentum, I have my mass, and I have my velocity. I can go ahead and punch that into my calculator. And I'm going to get 2.275 kilograms times mass divided by second. I apologize, I should have my calculator over here so you can see it better. Number 3, which object has more momentum? A 65 kilogram person running at 3.1 meters per second, or a 25 kilogram bird traveling at 12 meters per second? Be sure to show all your work and explain why. So this is going to be a two-set problem, so we're going to actually have two different equations going on. So I'll set up the first one on this side and the second on that side. So I'll do P equals M equals V equals, and I'm going to have that 65 kilogram person and that 3.1 meters per second. On the other side, I'll have P equals M equals V equals. I have a 25 kilogram bird traveling at 12 meters per second. Okay, so I'll go ahead and plug in my information on this side. Enter that into my calculator. $201.5 kilograms times meters divided by seconds. And then on this side, plug it into my equation. Will give me 300 kilograms times meters per second. Okay, I'm not done. I need to show all my work and explain which object has more momentum. I'm going to go ahead and say that the bird, I should write that down over here. The bird has more momentum because it's a greater number. Generally, these don't have the same velocity, but if something had the same velocity, the one that weighed more would have more momentum, and vice versa. All right, number 4. Excuse me. Which object has more momentum? A 500 kilogram car traveling at 10 kilometers per hour, or a 2 kilogram basketball pitched at 150 kilometers per hour? So we'll do our car over here. And we'll do our baseball over here. I'll plug it into my equations. We'll have 5,000 kilograms times kilometers divided by hour. That's going to be 300. Excuse me. Or 300. Okay, which one has more momentum? I'm going to go ahead and say my car because it has a greater value. Okay, we can go ahead and turn our page over. What is the speed of an 8 kilogram bowling ball rolling with a momentum of 16 kilograms times meters per second? So these are a little bit different because we are solving for a different number. We are looking for the speed or the velocity, so we do not know that number. We still have a mass, and we have our momentum. So if I write out my equation, I'm just going to plug the numbers into different letters here. So this is going to be 16 kilometers times meters per second. My mass I can plug in for 8 kilograms, but I do not know my V. So I'm going to divide each side by the 8 kilograms. This will cancel out. I'll be left with a V on my right side. Here I'm going to get 2. So if you're not confident with your math skills, you can use your calculator. Get our 2. Our kilograms will cancel out and leave us with meters per second. Number 6. Suppose a 4.5 kilogram meteor fell and struck Earth. If the meteor was traveling at 2,000 meters per second at impact, excuse me, what was the meteor's momentum just before it hit Earth? So again, I'm going to plug in, or I should say write down my knowns and my unknowns. So my mass is 4.5 kilograms. I have a velocity of 2,000 meters per second. I'm not sure of my momentum. Let's see. It's going to give us 9,000. Kilograms times meters per second. Number 7, Danielle hits a golf ball .05 kilogram, that weighs .05 kilogram golf ball, giving it a speed of 75 meters per second. What is the ball's momentum? So we're going to solve for P. Our M is going to be .05 kilograms. Our velocity will be 75 meters per second. So I'll plug in my 75 times .05, which will give me 3.75 kilograms times meters per second. Let's square that. Number 8. A ball has a momentum of 91 kilograms times meters per second and is traveling at 2.3 meters per second. What is the ball's mass? So I have a momentum. I do not have my mass, but I do have a velocity. We're going to divide that by 2.3 meters per second. Divide that by 2.3 meters per second. This will cancel out, and I can plug the rest into my calculator. Let's just say 39.6. Our meters per second will cancel, so we'll be left with kilograms. Lastly, a snowball with a mass of .085 kilograms hits a snowman's top hat and sticks to it. The hat and the snowball, with a combined mass of .22 kilograms, fall off together at 8 meters per second. What is the momentum of the snowball and of the hat combined? Okay, so here we're looking for that momentum. We have the velocity, they fell off together, and we have the combined mass. The author's trying to distract us with this other piece of information. Now, if we needed to figure something out just about the snowman's top hat or the snowball, that would be very valuable. But since we're looking for the combined momentum of the snowball and the hat, we only need this number. So I'm going to go ahead and write in my equation. And we're going to solve for P. And we'll square our answer. And that's it for this worksheet.